Well, as far as Part B goes, and the hints that you gave us, here's a list of the knowns, and the unknowns are things that I would like to know. First, we'll start off with the known. We have the velocity, we have theta, and we have the height of the two buildings. As far as the unknowns go, here's what I came up with. The weight of the robber, was he wearing sneakers or boots? Distance between the buildings, were there ledges on the buildings? And does he have loot? Is it in a backpack? Is it in a fanny pack? Or I'm sure that's extra weight added to the robber itself. And was the robber an athlete or not? Say, did he have any prior experience in long jump? If not, well, I feel sorry for him. Alright, well, so here's the equations that I came up with. I drew a diagram of my vertical and horizontal components. As you can see there, 10.5 cosine 10 and then 10.5 sine of 10. And those are what I computed to come out with. And this is the formula that I used to come up with the time that the robber spent in the air. It's a quadratic equation. Compute equals negative 6.12 meters, and I divided that by 9.8 meters per second squared, and I came up with 0.62 seconds in the air. So as far as the distance goes, it's rate times time, or no, not as far as distance goes. We have 6.2 seconds times my horizontal component, which is 10.34. I came up with a distance of 6.41 meters for the overall jump. And then this is how I came up with my magnitude as far as distance from, or my triangle. I don't know, I really know how to explain that. I converted my 10 feet from the top of the first building to the second building, came out to a 3.048 meters, and because it's in the downward direction, I threw a negative on there. There's my horizontal squared, and then my vertical squared, all under a square root, comes up with 7.14 meters. And then I calculated the angle between that, came out to a 25.27 degrees in a negative direction. So the first part of the question, as far as A goes, was the maximum distance between the buildings. For a safe jump, I came up with 6 meters between the buildings. Because the overall was 6.41 meters, the total length of the jump. So figured 6 meters would be a safe maximum distance between the buildings. And the final velocity, I didn't really think it was that hard of a question, or I might be overlooking something, but I came up with a 0 velocity because he's not going anywhere once he hits the other building. So I hope that was what you're looking for as far as the screencast goes. And we'll try again on Friday for the other one, which, by the way, is an error on the viewing on the video itself. It was not coming in, so I'm sure you'll tell us this in class on Tuesday. We'll see you later.